Okay, the front of this one started off with doing some of the stuff that we did in Chapter 5. So we had to do a couple sequence things. So for the first part, it talks about Jamie and her puppy. So since she got him when he was 1 week old. So that's going to be pretty important. So we're going to underline that 1 week old. And it tells us how much the puppy weighed. So we have 6.5 pounds. So you know those two things are going to go together. So then it says the puppy's weight increases by 0.75 pounds each week. So we need to write the first 4 terms of the sequence. Well, we know where it starts. So we know that we have 1 week old, so we can make weeks. We can set that to be n. And we also know that the weight, we can find out how much it weighs. That's what it's going to depend on. So this one, we can make t of n. So I can make a nice little chart. After 1 week, it's 6.5 pounds. After 2 weeks, well, we know that it's going to increase by 0.75 pounds. There's a little decimal point right there. So I need to add 0.75 with 6.5. So that's going to put me at 7.25 pounds. So then after a 3rd week, the puppy's going to grow again by the same amount. So that puppy's going to be 8 pounds. And then on the 4th week, puppy's going to increase again by another 0.75. So add to 8.75. So we have our first 4, 1, 2, 3, 4, and we got our first 4. So for part B, we had to figure out if it was geometric or arithmetic. Remember, geometric is when we're going to multiply. Arithmetic is when we're going to add. Well, since we kept adding every time, that's how we know it's going to be arithmetic. So it's arithmetic. And that's because we had to add every time. Now the last thing we had to do is write a recursive equation. And remember, our recursive equations, they always have the form of t of n plus 1 equals t of n, and the change is going to go here. And we also need our seed. t1 equals some number. Well, my change is I'm going up by 0.75 every time, so it's t of n plus 1 equals t of n plus 0.75. And my seed, t of 1, well, that's what it is after the 1st week. It's at 6.5. So we've got my equation, I've got my seed, so we're all set. We've got my recursive equation. So that's good to go. Question 2 was another one of these types of sequences. So we had to make a representation for our plane taking off. After 4 seconds, it's at 32 feet. After 5 seconds, it's at 128 feet. Most people chose to do a table on this one, so I'm just going to continue doing the table. A lot of people went back to 3, which is a good idea, because for part B we're going to need some lower numbers. So since we multiplied by 4 here, to go backwards we have to divide by 4. So we're going to go ahead and make that one an 8. 2 goes with 2. 1 goes with 0.5. And I can't fit 0 in there, so I'm going to put 0 all the way up here. I have to do 0.5 divided by 4. Well, that's 1/2 divided by 4 is 1/8, which is 0.125. So I did see one person did a picture. I did the table here. Graph works out. I did see some people doing the graph. Sequence, you could just write these out. That would be okay too. I do have at least 4 terms. So I've got 1, 2, 3, 4, 5. I got 6 terms. I got a lot of terms. I'm all set. The reason I went backwards here is because when I write my explicit equation, remember, that's going to have the form of t of n equals t0. Then we have the change, and it's geometric, so we got to put the variable all the way up there. So t of n stays as t of n. t0 I figured out with my table, that's 0.125. My change is times 4, multiplying by 4 every time, and then n just stays as n, so I get my variable n. The back of the test focused a bit more on the stuff that was in the current chapter, so we're going to check this one out also. First part we had to do is plot points on a graph. We did pretty well plotting the points on a graph. We can see we go all the way up to 20, so I could probably go by ones here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We just made it. Alright. And then over here we have our test percentage. And it looks like we're going up to maybe about 100. 0 to 100 seems like a normal range for a test. So I'm going to go from 0. Let's go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Oh, okay. That works out pretty well. Alright, so looks like we're going to have a pretty full graph. Now if you did something a little bit smaller here, because yeah, the numbers don't really go from 0 to 100, that's totally fine. That's okay. So I've got to plot these, so I'll plot these real quick. Okay, I've plotted my points. I put little check marks just to make sure I actually plotted all the points. That's about the only technique that we missed. I don't think we really need to watch me plot points. So I got my points on my graph. Did I answer the question? Yes, plot data points on a graph. Okay, we're all good then. So the next part says to draw a line of best fit on the graph. Okay, we can do that. I'm going to kind of freehand it because I don't see a ruler very handy. I'll do my best, but it does kind of look like this. So I'm going to go ahead and plot that. Looks kind of went like that. That's not bad. So a couple of points are a little higher, a couple of points are a little bit lower, a couple are on the graph. That's not too bad. Okay, drew my line of best fit. Describe the association. Well, we got a choice between positive and negative. This is sloping upwards, so that's positive, so I'm going to say positive. Then we have a choice between strong and weak. All the points look kind of close, so I'm going to say that that's strong. That line looked pretty easy to draw. If I wanted to, I could also say it's linear, because we did talk about linear and non-linear. So those would be my choices. Any two of the three would have been okay. So that's that one. So next we need to find the y-intercept. Now one thing to watch out for is this is the x-intercept. This is where it crosses the x-axis. The y-intercept on my graph is going to be somewhere down here. Depending on the line you drew, it could change. I know some people went through 0, 0. Mine does not, so I got to go the long way, which I guess is good. So what I'm going to do is I'm going to pick 2 points that are on my line, not the data points. They could be. I could pick some of these ones that are on the line, but I'm going to pick 2 points that are on my line. So I'm going to look for crosses. So right there it crosses. So I'm going to pick that one. And I cross right here. Do I see any better crosses? I like this one. All the way up there. So I've got my coordinates. I can figure out my coordinates of my 2 points. I've got one of them's at 9. 5, 10, 15, 20, 25. Okay. And my second point is at 19. That's good. That's a good number. And then 75, 80, 85. Alright, so I've got my 2 points. Now I have to get the line for my 2 points. Alright, so that's going to be the slope equation. That's the delta y over delta x. Y2 minus y1 over x2 minus x1. I'm going to call this one x1, y1, x2, y2. So I get 85 minus 25 over 19 minus 9. That's really good because that's just going to give me 10. I like to divide by 10. I can do that pretty well. So let's see, did I do that right? Yeah, that looks good. So then 85 and 65, so that's going to be 60. So if I divide 60 divided by 10, I end up with 6. And remember, this is going to equal my slope, so I should probably have put an m equals over here. So I know that m equals 6. So now that I have my slope, now I can use slope-intercept form. Y equals mx plus b with my slope to find out what my y-intercept is, what my b is. So I'm going to choose 9. 9 and 25. So I'm going to have 25 equals 6x plus b. Oop, I know x. Shouldn't have wrote an x there. 25 equals 6 times 9, because my x is 9, plus b. So I can use this equation. I plugged in and solved for b. So we plugged in and solved for b, so we take 6 times 9, so this is going to be 25 equals 54, plus b. I need to get b by itself. That's the variable I want to get by itself, so I have to do minus 54, because I'm adding 54. So that's going to be 29. So I get negative 29 equals b, so that's my y-intercept. So I know that's my y-coordinate. Now the x-coordinate of a y-intercept is always 0. So as long as you put 0 there, you are kind of on the right track. So this is kind of the long way. If I got lucky, I might be able to read it off of my graph. I might be able to just see where the line crosses, but I can't really tell from here. I'd have to make my graph a little bit bigger. So part D, we have to interpret this. So if I know that my y-intercept's at negative 29, that means that if I eat 0 Smarties, because Smarties are my x, I will score a negative 29%. Does that make sense? Well, no, unless the teacher's really mean and gives you negative percents on a test. Normally you can't get a negative percent, so I'd say no. No negative percents. Alright, and the last question says we need to find the residual. So to get the residual, we're going to use the residual formula. The residual formula is going to be the actual minus the predicted. And that's our residual. So here we can see that Danny was the person who had 12 Smarties. So if we go all the way up here, we can see that 12, his actual was he actually got a 40%, so we're going to put a 40% for his actual. And then it says he predicted that he would get a 65%. So we know that his predicted is 65. Sometimes you'll have to find it on the line. In this case, we didn't. That's going to be our residual, so we end up with negative 25. So he did worse than he predicted, so he's got a negative residual.